Good morning. Today I'm going to present the project for the week 1 CE 5700. Today I'm going to show that I have plotted a cone in MATLAB and a curve surface and a curve in a cone. Okay, the parameterization of my cone is x1 is equal to z cos theta, x2 is equal to z sin theta, and x3 is equal to z, where the limit of theta is from 0 to 2 pi and limit of z is from 0 to 1. And I have verified, first I have verified the parameterization by hand, then I have done it in the MATLAB. The cone is having two surfaces, the bottom surface and the curve surface, and the cone is having only one edge, it is the bottom curve edge. So I have given the information in the MATLAB as I have given theta is from to theta, the maximum limit of theta is 2 pi, maximum limit of z is 1, and I have given the theta segment as 10 and divided the length segment as 5, and I have given in the body para as the body para the parameterization, and in the body grid I have given the limits, and for the surface I have given two surfaces, and for the body curve I have given the curve. And this is the cone which the MATLAB has given me after coding the parameterization in the code. And the height of the cone is 1 unit and the radius is 1 unit, so it is a right circular cone. The parameterization of the curve is x1 is equal to z sin theta, x2 is equal to z cos theta, and x3 is equal to z. I have drawn a line from the bottom to the top through the surface of the cone. It is it's the slanting height of the cone. So I'm getting the red line shows the curve. So this is the code for the line curve I have drawn, and the length of the curve given by the MATLAB is 1.4124. I have verified it through my hand calculation with the same parameterization as x1 is equal to z sin theta, x2 is equal to z cos theta, and x3 is equal to z. And I have first differentiated x1, x2, and x3, and taken the determinant of it, and I got minus 2 root z. And when I integrate it from 0 to 1 by dz, I get the length of the curve. So when I integrate from 0 to 1 root 2z dz, I get root 2, which is 1.414213, which is the same value as the length of the curve I have got from the MATLAB code. So which is the same value. And I have taken the parameterization of the surface, and I have taken the surface as the curved surface of the cone, and which also has the parameterization as x1 is equal to z cos theta, x2 is equal to z sin theta, and x3 is equal to z, and where theta is from 0 to 2 pi and z is from 0 to 1. Okay, the blue lines in the figure shown is the surface I have taken, and the code in the MATLAB for the surface is this. And I have, you can see that x dot z into t into cos theta into t into z, which means that I have changing my z and theta at the same time to get the surface. So the area of the surface given by the MATLAB code is 5.1175. I have made a hand calculation of the surface area. I have differentiated the parameters x1, x2, and x3 by dz and d theta, and I cross multiply it, and I got z cos theta and z sin theta and z. I took the determinant of it, I got root 2 z, and I integrate root 2 z by d theta and dz from 0 to 2 pi and 0 to 1 to get the surface area, and I got root 2 pi as the surface area, and which is 4.44. Actually, it is the surface area of the cone, which is the surface area is equal to pi rl, and here r and as it is a right circular cone, r and l are same, so I'll get root 2 r square pi, and here r is 1, so it is root 2 pi. So the equation is which I have derived is correct. It is 4.44, and the value which got by the MATLAB code is 5.1175. There's a small error. The error is because the segment I have taken is a small 10 segments. As it is a circular cone, it should have a lot of segment to get a proper value. As I took only some small segment, there is a small error in it. Okay, thank you.